Welcome to Matematika. Today we're going to do problems and solutions of 1.5a polynomial functions and complex zeros. We'll start with question 1. A polynomial f of x equals x to the fifth power plus 7x to the fourth plus 17x cubed plus 47x squared plus 72x minus 144 has zeros at x equals negative 4 and x equals negative 3i. A. Determine the remaining zeros of f of x. Okay? By the fundamental theorem of algebra, if you remember, this function has 5 complex roots. You know what complex roots consist of? Non and non-real roots. Because since the degree is to the fifth power, that's why we say it has 5 complex roots. And we see one of the given is x equals negative 3i. So we were given 2 of the roots, which means 3 are still remaining. We're still going to look for those 3. Since the polynomial has real coefficient, we can apply the complex conjugate theorem. Remember in the previous video. And then we can create factors for the known roots and use the polynomial division for factor f of x and find the remaining roots of this function. So if you remember that if a number, let's say I use k is a 0 of f of x, then we could say then f of k is 0. So it follows that x minus k is one of a factor, right, by the factor theorem. I hope we have gone through this. So we have from x, so the given from that, the given is x is equals to negative 4, then one factor would be x plus 4. If you reverse that, you come out with x minus 4. And the other one, x is negative 3i. We have a complex number given. So as factors, then we, as factor of f of x, so what can you say? Since the polynomial has a real coefficient, then we can apply the complex conjugate theorem, which says if negative 3i is a root, then positive 3i is also a root. Okay? Is also a root by the complex conjugate theorem. So what we have is x plus 3i, that's one root, that's one factor, and we have another factor, x minus 3i. Okay, we found that one factor already. So what we need are the 2 more factors. Okay, so if we try to multiply this together, x plus 4, x plus 3i, then x minus 3i, this will become x plus 4. You know, x plus 3a and x minus 3a, that's the sum and difference of two squares. So it will become x squared plus 9. It is not x squared minus 9. Why? Because we have this we have this I times I, remember? It becomes an I squared, and I squared is negative 1. A negative 1 multiplied to a negative 9 will become a positive 9. That's the reason behind it. So by using the distributive property, okay, x times x squared, that will become x cubed plus 4x squared plus 9x, FOIL, you distribute, plus 36. Okay, by distributive property. Alright. Now, what we're going to do, next we can use the polynomial, this polynomial given, because we're still looking for those two. Let's use division. I hope you remember division of polynomial. I will have this. Then write the function x to the fifth, 7x to the fourth, plus 17x cubed, plus 47x squared, plus 72x minus 144. And then divided by what we come out of the product of the three factors. We have x cubed plus 4x squared plus 9x plus 36. Okay, we have 4 terms as our divisor, and we're going to use 4 terms first in our dividend here. Okay, so the first is x to the fifth divided by x cubed. So what am I going to multiply to make the term to x to the fifth power? So I will multiply x squared. So because x squared times x cubed, that is x to the fifth power. All right. We want to eliminate some terms. X squared plus 4x squared, that is 4x to the fourth. X squared times 9x, that is 9x cubed. Then x squared times 36, that is 36x squared. So what are we going to do? We have to subtract in order to cancel out and change the sign, everything inside. So x to the fifth and x to the fifth is cancelled. All right, what? 7 minus 4, that is 3x to the fourth. 17 minus 9, that is 8x to the third. And then 47 minus 36, that is 11x squared. Bring down 72x for your fourth term, because our divisor has 4 terms. All right. Now your basis will be 3x to the fourth divided by x cubed. So what I'm going to multiply to make it the x cubed to 3x to the fourth power. So I'm going to multiply with 3x, right? 3x times 3 times x cubed, that would become 3x to the fourth. Okay. Then 3x times 4, 3 times 4, that is 12x cubed. Then 3 times 9, that's 27x squared. Then 3 times 36, that is 108x. So we do subtraction and change the sign, the whole thing here. In order to, this will become negative, so the 3x to the fourth is cancelled. So we have now 8 minus 12. So we have a negative 4x cubed. 11 minus 27, that's 16x squared. 72 minus 108, that is negative 36x. Then bring down negative 144. Right. So next would be, what are we going to multiply to x cubed to make it into a 4x cubed? So we multiply it with 4. So 4 times x cubed, that is 4x to the third power. Then 4 times 4, that is, this is negative 16x squared. Negative 4 times 9, that is negative 36x. Negative 4 times 36, that's negative 144. Now, if you look at this, you say, oh, they have the same number. Now, I could, cancel out. No, you cannot cancel out because they are both negative. You have to change the sign. So what we're going to do is to subtract. To make this into a positive, everything is positive. Change the sign so that the positive and the negative can be canceled out, and your value now is 0. Okay? Whew. So many numbers in division. I hope you remember about it. So the result, what is our result? Our result is x squared plus 3x minus 4. This is the time we are going to factor out. What's the factor? X plus 4 and x minus 1. That's the factor. Setting these factors to 0, we could find the remaining roots. Our roots would be x plus 4 equals 0. So this will be x equals negative 4. And x minus 1 equals 0. This will be x equals to 1. So we found earlier from here one of the roots, x plus 3i, which is x equals 3i. Okay, from x minus 3i right here. So that would be one of the factors. So we found the 3 factors already. So you are asked to determine the remaining zeros. So what is our 0? We have a negative 4. We have x equals 1. And we have x equals 3i. And the one given is x equals negative 4 and x equals negative 3i. So we have 5 roots. Okay. Now you could check the zeros given to use. Then you can check it by multiplying it back if you are really getting the function that is given. So I'll give you a chance to do that by yourself and check if our answer is correct. Okay, let's go to the next question here. State the multiplicity of the zeros. So the full factorization of the polynomial. So if we go back to the factor, we have the factor of the function x minus 1 yes, we have x plus 4, then another is x plus 4, then we have x plus 3i, and x minus 3i. So if we're going to simplify that, we have x minus 1, but we have 2x minus 4. So we can see a multiplicity of, 2. So in other words, you have x plus 3i, x minus 3i. So the multiplicities of 0, we determine the number of times that the corresponding factor of its zeros occur with the factor. So in the factored form, we could say x equals 1 is a 0. What is the multiplicity of x equals 1? It's 1. It's 1 right here to the first power. While x equals negative 4 is a 0. What's the multiplicity of x minus 4? It's 2, right? Is 2. How about x equals negative 3i? Is also a 0 with multiplicity of is 1. While x equals 3i is a 0 with multiplicity of 1 also. So if we add up 1 plus 2 plus 1 plus 1 is equals to 5. And that equates to the degree of the function that is given. I said there are 5 complex roots and you have 5 zeros with 5 multiplicity. Okay. Let's have problem number 2. A polynomial function wx is shown in the table. Find the successive. Okay. I didn't write the question. Find the successive differences. Remember the degree? You can find it by using successive differences until you find the successive differences. That means find the degree of the polynomial function. Right. So we can start finding the difference. Okay, this is, I like this. 6 minus 1, you have 5. 31 minus 6, you have 25. 100 minus 39, you have 69. 229 minus 100, you have 129. 426 minus 229, you have 197. This is the first difference. By looking at it, all the numbers, all the difference are different numbers. Okay, you cannot see anything that is the same. Let's do another difference. Say successive differences. So let's do another one. 25 minus 5, that's 20. 69 minus 25, that's 44. 129 minus 69, you have 60. 197 minus 129, you have 68. This is the second difference. Still different numbers. Let's do another difference. 44 minus 20, that's 24. 60 minus 44, that's 16. 68 minus 60, that is 8. Still, you don't come up with a constant difference. So we'll do some more. 16 minus 24, that's negative 8. 8 minus 16, it's negative 8. This is the fourth difference. So you come out with a constant value of negative 8. That means the degree of this function is 4, or it is to the fourth degree, right? Okay, let's move on. For each of the polynomial function, find the intervals for its condition. A, f of x is x squared minus 5x plus 4. When is f of x less than or equal to 0? Okay. Let's factor out so that we can find the 0 or where it intersects. X4 is 1 and 4. Okay, we'll have 1 and 4. Let's equate the function to 0. So the factor would be x minus 4 and x plus 1. Since the middle term is negative, you have the greater value of the factor should be on the negative. So the roots here from x minus 4, we equate this to 0. So this will be x equals 4, and x plus 1 equals 0, then x is negative 1. Oh, sorry, this should be, I think I made a mistake on the factor. Both should be negative because the last term is positive. Okay, I have to make some changes here. So this will be also x minus 1 equals 0. So this will be x equals 1. That's it. Okay. If we try to look at this in a graph, I usually want to visualize something in a graph. 2, 3, 4. This is 4. This is 1. So this is where our roots are. the x-intercept, where it should be that the function is less than equal to 0. Let's divide this. On the left side of 1, it's negative infinity. On the right side of 4, it's positive infinity. So whatever possibilities here that the value is, less than or equal to 0, then that's it. That is where the intervals, we're looking for the intervals. Okay, so in this case, if we use from negative, I will use the first part here, from negative infinity to 1. Okay, what is going to happen with our values there if we substitute a certain value in the function? Say, for example, I will choose from there, I will choose a negative 2. You can find all the numbers here to check what will come out with your, with your value. So I will try to check if I choose x at negative 2. So what happened? Negative 2 squared minus 5 times negative 2 plus 4. So I have 4 plus 10 plus 4. So I have 18. And 18 is positive. So we come up a positive values here when we're going to plug in any of the numbers that are from the intervals of negative infinity to 1. Any number would come out with a positive once you plug in to those values. You know that 1, okay, that is a 0. We have a value of 0 there because that's the root. And same thing with 4 is a 0. But how about the values in between 1 and 4? The interval of 1 and 4? So, for example, I choose a number between 1 and 4. Let's say I choose 2. So that would become 2 squared minus 5 times 2 plus 4. So I have 4 minus 10 plus 4. I come out with a negative value. 8 minus 10, that is negative 2. So from here, from 1 to 4 interval, I have a negative. So let's do the interval of 4 to infinity. 4 to positive infinity going to the right. So I will check. I will choose any number from here. So I will check if I choose the value of x. Let's say x equals 5. I want to know. That would be 5 squared minus 5 times 5 plus 4. So I have 25 minus 25 plus 4. Cancel. So I have 4. And 4 is a positive. So positive, negative, positive. So the intervals of 4 to infinity, it's positive. All right. Less than equal to 0. So this is included. These are zeros. That would be equal to 0. So f of x, and it's less than. So it should not be greater than 0 because the function there is either less than or equal to 0. So if I choose the positive side, 4 to positive infinity or 1 negative infinity to 1, it is greater than 0. Right? These are greater than 0, greater than 0. So we cannot choose that. We can choose this interval from here. So what would be our interval? On the interval of what? Included 1, because 1 is 0, and 4. That's 0. And in between 1 to 4, you come up with a negative value when you plug in to the function. And that answers to the question when it's less than or equal to 0. So that's it from that interval. That's how you're going to check. For each polynomial function, find the intervals again for its condition. So the condition here for B is g of x is x squared plus 17x plus 70 when g of x is greater or equal to 0. Is greater or equal to 0. Remember that. Greater or equal to 0. Let's look for our zeros first. By factoring the given, this will be all positive, so no problem. X plus 7, and then x plus 10. Okay, 10 plus 7 is 17. Come out with the middle. Okay, equate and get the equate that to 0 to get the root. X plus 7 equals 0. So x is negative 7. And we have x plus 10 equals 0. So x is equals to negative 10. Okay, let's look at it. This is what I usually do when I'm asked something like this. I would like to visualize it. So our, let's say somewhere here, 1, 2, 3, 4. Okay, I just do this way. Let's say negative 7 is here. Negative 10 is here. So this is where our roots are. So in other words, the function here is 0. This is the zeros. All right. So in other words, this is the negative infinity, and this is the positive infinity from here. Negative 7 towards the right. So we have to divide it into 1, 2, 3, 4, 5. Okay? So I will start with, let's say the first one there is negative infinity to 10, the interval, to negative 10. Negative infinity to negative 10. So let's say I will choose one number. Let's say if x is negative 11. So the function is x squared plus 17x plus 70. So negative 11 squared, all right, plus 17 times negative 11 plus 70. So negative 11 squared, that's positive 121, then 17 minus times 11, that's negative 187, then plus 70. So you add 121 plus 70, 190 minus 187, you come up with 4. So that means the interval here is positive. Okay? When you plug into the function itself, the values are positive. How about the interval of 10? 10 is 0. Then let's have the interval of negative 10 to negative 7. Let's say I use the number between here, negative 7 and negative 10. Let's say I use negative 8. Let's say what happened. Negative 8 squared plus 7 times negative 8 plus 70. So this is positive right here. 64 minus 136 plus 70. 164 plus 70 equals negative 2. So what we have in the interval here is negative. And you have, when it's negative 7, it's 0. So how about negative 7 to, the interval of negative 7 to infinity? Let's say I use the number greater than negative 7 to, let's say I use 8. Okay, so I just use 5. Just lower that down. So we have 5 squared, 17 times 5, plus 70. So 25 plus 85 plus 70, we have 110, 180. So it's positive right here. Okay, we have that. So what interval g of x, when it's greater or equal to 0? Okay, so where is the positive? From here, because it's greater. So we'll look for the positive. We don't get the negative. Okay, if you have, so our interval from negative infinity and negative 10, because it says equal to 0, so negative 10 is included, right? Because if not, if just say less than, right, this is our bracket there. And we have another one from negative 7 to positive infinity. So negative 7 is included, so we put a close interval there in the positive infinity. That is where the given, okay, g of x greater equal to 0 on the interval of negative infinity, between intervals negative infinity and negative 10, and negative 7 and positive infinity. So this one gives out the answer. All right. So we have the problems and solutions of polynomial functions and complex zeros. So I'll see you in the next 1.5b. So what I can say, if I can do it, so can you. Please don't forget to hit the like button and subscribe if you haven't subscribed yet. See you.